Hi, Year 9, it's Mr. Ereaut here, and welcome to another lesson. Today we're learning about altering conditions. So basically, how, if we change temperature or pressure, will that affect a reversible reaction? What will happen to the amount of product and the amount of reactants that we have? So on the right there, as you can see, we've got our key reversible reactions kind of diagram, which kind of just tells you that eventually a chemical reaction, if it's reversible, will reach an equilibrium point where the amount of product and the amount of reactants making each other will equal the same thing. So to start with today's lesson though, please, I'd like you to do some revision questions to start with. So can you please pause the video and answer these questions on this slide, please? Okay, so hopefully you've managed to answer those questions. Let's go through the answers now. So, first question, what's an independent variable? It's a variable that you deliberately change in an experiment. Okay, it's the variable you deliberately change. What does splat mean on a graph? It's scale, plot, line, axes, and title. Okay, so those are all the things you need to remember doing a graph. So anytime you get asked to do a graph question, whether it's a bar or a line graph or scatter graph, always remember splat and then just tick off whether you've done all of those points. What is dynamic equilibrium? It's the point at which the forward and reverse reactions are equal. So A and B, so all the reactants are making the products at the same rate in which the products are making the reactants. What is a closed system? It's a system where energy can be exchanged but not mass. So if you remember that bottle, we have a sealed bottle. So if you put hot water in a sealed container and then screw the lid on, that's a closed system because you can release energy out of that, but you won't release any mass, okay? It will still have that water in it at the end. It will just be colder because it's lost energy. Concentration affects the rate of reaction the same as pressure does. So remember, when we talk about rates of reaction, pressure and concentration go hand in hand because they work the same way. Collision theory, so particles need to physically collide, and when they physically collide, they need to have enough energy, or the activation energy, in order for a chemical reaction to actually occur. And then explain how surface area affects the rate of reaction. So there's more particles available for collisions to occur on, which means that there'll be more collisions and therefore more successful collisions and therefore a faster rate of reaction. So on to the lesson, altering conditions. Make sure you give yourself a score there so you know how you're doing. So we're going to look at two things today. We're going to look at the effect of pressure and the effect of temperature. So how, if we change either of those, will they affect the dynamic equilibrium? So in a previous lesson, we learned about Le Chatelier's principle, or Le Chatelier principle. So when a change is imposed on a system in equilibrium, the equilibrium will shift to counteract the change. So basically, if we put more pressure on or less pressure on a system that's really achieved dynamic equilibrium, that point will shift again. So the amount of product and reactants that are there will change if we change the pressure or if we change the temperature. So we're going to have a look firstly at what happens when we change pressure. So if we add more pressure or if we take more pressure away. So if we increase the pressure or decrease the pressure. Now this will only happen if all of the reactants in the product are gases. If you've got any reactants or products that are solids or liquids, this will not work. Because if you remember, you can't actually change the pressure on a liquid. Okay, they're incompressible, but gases are compressible, which is why it has to be gases. So if we increase the pressure, so we need to remember firstly what pressure is. So pressure is the amount of gas particles in a container. So if I've got two containers one with a higher pressure and one with a lower pressure, the one with the high, if they're the same volume, so the same two same size bottles, but one's under a high pressure, one's on a low pressure, the one under the high pressure will have more gas particles. Even if they're the same mass and they have the same number of atoms, if the bottle with high pressure must have more particles of gas. Okay, so it's the amount of particles of gas that changes the pressure. And so if you increase the pressure in a reversible reaction that's at dynamic equilibrium and all the particles are gas, what will happen is it'll bring about a reduction in the total number of gas particles. So the equilibrium will shift so that there are less gas particles in the container. So say we look at this here, okay? N2O4 forms 2NO2. Okay, they're both gases, they both got the same amount of atoms, they both got 2 nitrogen and 4 oxygen particles. The difference is there's one particle here, so see how there's no number out the front, which means there's only one particle here, so N2O4 are all joined together, while here there's a number out the front, it's 2, which means we've got 2 particles. So each of these particles are individual molecules, sorry. So in each of the molecules there's 1 nitrogen and 2 oxygen atoms. So there's actually 2 molecules here, or moles here, and there's only 1 mole here. So if this reaches equilibrium point, okay, and we form this, 1 mole here and 2 moles here. If we increase the pressure, okay, the equilibrium is going to shift less because we want to have, it will make less particles basically. Because it's being squished together, it means that the particles will try and decrease so the pressure stays the same. So you'll then form bigger particles, but there'll be less of them. So if we look at this again, please watch this video because he has some really good diagrams in here which kind of give you a bit more information in a visual representation of how dynamic equilibrium shifts the position of the particles. So either download the PowerPoint on EduLink and then click on the hyperlink, or just type it right out from this video here. So pressure is caused by gas particles hitting the side of their container. The more molecules you have in the container, the higher the pressure will be. Okay, we've already said that. So if you put more particles in a container, the pressure will increase, or if you decrease the size of the container, the pressure will increase because there's going to be more particles there hitting the sides of the container. And then the system can reduce the pressure by reacting in such a way as to produce fewer molecules. So basically, the system wants to have less molecules because if you're increasing the pressure, it's trying to reduce the pressure itself by reducing the amount of molecules inside. So if we look at this reaction here, N2 plus 3H2 forms 2NH3. Can you tell me, please, which side has fewer molecules? And if I increase the pressure, which way will the equilibrium shift? Okay, so it's exactly the same as the video you should have watched from the previous slide. So if you're stuck, again, watch that video again to help you answer this question. So which side has fewer molecules and which way will the equilibrium shift? Pause the video now and answer that question. Okay, so because there's more molecules on the left, increasing pressure will cause the equilibrium to shift to the right where there are fewer molecules. So there's 2 molecules here, so 2 here. We've got 3 plus 1 because there's 1 there even though it doesn't say it. So there's 4 molecules on the left side and 2 molecules on the right side. So the equilibrium will shift to the right because there's fewer molecules and it's trying to reduce the pressure. So the forward reaction increases to decrease the pressure. So it shifts to the right. the forward reaction. That direction is where the reaction will move to. So we're now going to look at the effect of temperature and how temperature affects the equilibrium point. So adjustment in the equilibrium is determined by whether the reaction is endothermic or exothermic. So in order to answer a question on which way the equilibrium will shift if you change the temperature, you need to know which direction is endothermic and which direction is exothermic. Okay, so if the reaction is exothermic, an increase in temperature shifts the equilibrium towards the reactants. So like this is exothermic. So if we increase the temperature, it will shift the equilibrium left to the reactants, because these are the reactants. And if we decrease the temperature, it will shift the reaction towards the products. So what's happening here is, so it's exothermic from reactants to products and endothermic from products to reactants. So if we lower the temperature, what happens is this reaction will take that energy in. So it will take that energy in, basically means it's got more activation energy, which means more of these reactants can form the products. Okay, so lowering the temperature increases the reaction because it's absorbing that energy in and then releasing that energy, and then vice versa. If we raise the temperature, it increases this reaction and makes less ammonia. Again, there's two more brilliant videos which describe exactly how this process works. So have a go at looking at those videos to inform you of, or to help you out for the next few slides, which are questions. So, key points before we get on to the questions. Forward reaction, nitrogen plus hydrogen forms ammonia. Back reaction, ammonia forms nitrogen plus hydrogen. So these are our reactants and the ammonia is our product. So forming ammonia releases heat. Therefore, it's a what type of reaction? Pause and write that down. You should have said it is exothermic. Well done if you did. Backwards reaction is opposite. So the opposite of exothermic is therefore endothermic. Good. Okay. When both reactions are happening at the same rate, it has reached the what? Pause the video, answer that question. Hopefully you said dynamic equilibrium. Remember, if the forward reaction and backwards reaction, or reactants are making products and products are making reactants at the same speed, that is called the dynamic equilibrium. So task, and we'll have a look at that tomorrow's lesson, Tuesday. Draw this reversible reaction, include arrows for exothermic and endothermic. Okay, so you're just literally drawing one arrow at the top for exo or endothermic and one arrow at the bottom for exo or endothermic. Not too hard. Okay, here's a slightly more difficult question though. So changing condition will cause the system to adjust so equilibrium is maintained. If we decrease the temperature of the ammonia reaction, what will happen? So the ammonia reaction from the previous slide, if we decrease the temperature of that ammonia reaction, what will happen? Pause the video and answer that. If you forgot from previous slide which direction's exothermic, which direction's endothermic, pause the video or rewind it. It's like about 30 seconds so you can have a look at that diagram. Otherwise, pause the video and answer the question. Okay, hopefully you've answered that question. Here is the answer. So the forward reaction will increase because it is exothermic, so more heat will be released, which counteracts to decrease temperature and make more ammonia. So equilibrium has shifted to the right. So we're making more product. So if you wanted to make more ammonia in a chemical reaction, for example, you would heat the reaction up, so provide more energy. So you'd shift the reaction to the right. Okay, next question. How will a high temperature affect the reaction? So if we have a high temperature, for the ammonia reaction, what will happen? So hopefully you've answered that question. So if we have a high temperature, it will affect the reaction in the following. It will favour the backwards reaction to absorb heat energy, so less ammonia is made. So the equilibrium will shift to the left. So making ammonia, it's important for the industry. So what conditions must be chosen to provide a high yield so maximum profits can be made? So what two things can we change in order to increase the amount of product? Well, there's only two things we've talked about today, because there are only two things. It is either pressure or temperature are the two important conditions that must be kept constant for the best results, because they're the only two things we can change. So have a look at this, please. Pause the video. Can you find the 10 mistakes in here? Okay, hopefully you've had a read through. Some of these are spelling mistakes. So here we go. Here are the right answers. Make sure you're marking your work as we go. Hopefully you managed to find those 10 mistakes. Alright, so we've got some more difficult questions now here for you. So you're going to have to pause the video again. So what has the largest surface area, the moon or a grain of sand? An experiment used 3.75 grams of calcium carbonate, CaCO3, when it reacted with hydrochloric acid in 33 seconds. Calculate the mean rate of reaction, write a word equation for the reaction, and then write a balanced symbol equation with state symbols. So you need the solid, liquid, gas, or aqueous, and you'll need to balance it and make sure there's the same amount of atoms on the reactants as the products. Question 7, how does a catalyst speed up a reaction? 8, name 4 factors that affect the rate of reaction. 9, what is the catalyst found in the liver? And 10, what does dynamic equilibrium mean? So pause the video now and answer those questions. So these are for the higher students, so those in the grammar stream. If you're on the H band, don't worry about answering these questions. If you are in the grammar stream, can you please have a go at answering these 3 questions at the bottom using the information at the top? So sulfur dioxide plus oxygen forms sulfur trioxide. It's a reversible reaction. So 2SO2 plus O2 forms 2SO3. Okay, it's exothermic in the forward direction. So sulfur dioxide plus oxygen forms sulfur trioxide. That is exothermic in that direction. So answer these 3 questions if you're in the grammar stream. So, answers. So the moon has a larger surface area than a grain of sand. That's obvious. However, if it was a ratio of surface area to volume, a grain of sand would actually have a higher ratio. Experiment used 3.75 grams of calcium carbonate when it reacted with hydrochloric acid in 33 seconds. Mean rate of reaction, okay, it is the amount of reactant divided by time, which is 3.75 divided by 33, or 0.11 grams per second is the mean rate of reaction. Word equation, calcium carbonate plus hydrochloric acid. We know it forms calcium dioxide. 2 other things it forms is water and a salt. So got water there, H2O, and then the salt is what's left, which is calcium chloride. And then the balanced symbol equation, CaCO3 plus 2HCl forms CO2 plus H2O plus CaCl2. And then state symbols, solid, liquid, gas, liquid, and then the salt is aqueous because it's dissolved in the water. 7, how does a catalyst speed up rate of reaction? Provides a lower alternative energy pathway, so there's less activation energy needed. 4 factors that affect rate of reaction. I bet you're sick of them by now. Concentration, pressure, temperature, catalysts, and surface area. The catalyst found in the liver, you might need to look this one up. It's catalase, but I just love that because it's a catalyst, and therefore, catalase, good enough. And then, what does dynamic equilibrium mean? It's where the forward and reverse reactions are equal. So the products are making reactants at the same rate at which the reactants are making the products. And then your extension questions. Since there are 3 molecules on the left and only 2 molecules on the right, by increasing the pressure, the equilibrium will shift in towards the right in the forward direction. So we'll start making more of the product. Answer 2, by making it hotter, the equilibrium will shift to the left in the reverse direction as high temperatures favor the endothermic reaction. Since it's exothermic in forward direction, it must be endothermic in the reverse reaction direction. And then lastly, catalysts provide lower alternative pathways, meaning the reaction will happen faster as less activation energy is required. Hope you managed to answer all those questions and you enjoyed the lesson. And as always, stay safe.